right, so I have the task of sort of talking more about visualization in notebooks, and I am not going to wow you with beautiful pictures like this one that Joe and collaborators have put together, and some of those that you've seen already in Vapor and Visit and ParaView and the stuff that Tommy does. But I do want you to remind you that these rather mundane plots are also visualizations. And one of the things to keep in mind as you're dealing with data and dealing with your data and large scale simulations and everything else that you're doing is that the purpose of visualization really is to gain some knowledge about what you're doing, right? So Ben Schneiderman, who has done a lot of work in visualization, has this sort of quip about not the pictures being the end product, but really understanding what the data, what the simulation, what the process is giving you in the end, right? So that insight becomes important. And sometimes that requires nice visualizations like this that really embody sort of the physical manifestation and things like that, and can align with how we understand the world and things like that. But also they can be, these more mundane plots as well. And so, one of the things that I do a lot of is sort of just data analysis of maybe not as large scale data sets. But I like to think about this idea of taking data and doing computations on it, generating some output, and then, reflecting on that output, right? Perception, cognition, hopefully generating those insights and knowledge. And of course, as we go along with that, what happens along the way is we often have to go back and create more outputs, change the computation, look at different data, rerun the simulation, things like that. And so this exploration step is something that's kind of built into data analysis. And so visualization is certainly a part of that. And going from output back to computation is something that I've thought a bit about, right? This idea that one output through our understanding sort of allows us to drive more computation, generate more outputs, generate more understanding. And so I think notebooks, sort of a comparison here from a Jupyter slide is sort of showing a notebook on the left-hand side and a Python script on the right-hand side. And some of the features that Tommy already mentioned are things like being able to look at these rich visualizations, having sliders, interactive sliders sometimes that you can sort of dynamic or recompute things just by moving a slider, having richer text marked down and coded in sort of these notebooks as well. And I won't just sort of just paging through the notebook, we see cells, sort of the outline in gray, and then the outputs or sort of the pieces of the thing that are in below those gray boxes, as well as text that helps explain what's going on throughout the notebook. So it's not just code and results, there can also be these explanations, this literate programming idea that Knuth likes to talk about. And so I think notebooks are great for this sort of exploration tasks, right? You have smaller, more digestible blocks of code. You have these richer outputs, not just text, you're not limited to just text. You have this ability to kind of have code in one cell that leans on the outputs of another cell. And you have this ability to kind of jump in wherever you want. So you're not sort of limited by running the whole script to generate the output. If you want to tweak something and just run a couple cells, maybe it's at the end of the analysis or something like that, you can just run that bit of code. Notebooks are also great for sort of explanation, right? I've hinted at this with the idea of text, and also there are like rich widgets that people have designed, say this one for gene expression data, where you can kind of look at a matrix of things like that and really interact with the data after you've gotten it into this notebook environment. And so one of the things I think about is this exploration task that notebooks support, as well as this explanation task and the ability to send someone to a notebook sort of that encapsulates your results, that discusses what you found, and how you go from one to the other, right? Because often we want to get to the result, we're sort of just blow through things, we're not going to maybe document it as well as we should have, and then how do we get that ready for more general consumption, right? Like we want to document it, put it out as part of the publication along with maybe a paper. And so I think a couple things that become important here that I've thought a bit about are sort of improving the displays in notebooks of the outputs, and then also thinking about improving the reuse, some of these problems and sort of how the cells all link together. And so to illustrate this, You may, if you've done any work in notebooks with Python, sometimes when you generate more complex data structures, you end up with outputs that aren't really as pretty as you'd like. You have images, but they're displayed as text, and you have tables, but they're misaligned because they're embedded in dictionaries and things like that. And so one of the things I've worked on a little bit is trying to improve those displays so that output can be more, can be analyzed a little bit easier than trying to sort of go back and do things with code. You can sort of dig down into the data instead. And then another piece that you may have run into if you've done work with notebooks, specifically in Jupyter and the Python environment, is sometimes when you're redefining or mutating a variable in one cell, that may break things in another cell. If you execute some of this stuff out of order, that can cause issues as well. Or maybe you edited something but forgot to run that code before you ran another cell. You can get yourself into these sort of strange situations where what you think should happen doesn't actually happen. And again, to illustrate this simple data set, looking at soccer players, analyzing them using the pandas library for sort of data, sort of looking at data. And one of the things that you'll notice, didn't highlight that, sorry. One of the things that you'll notice here is their df keeps on being redefined. That's sort of my data table, my data frame. And so knowing exactly which df I'm referring to, is the one from cell 5, cell 6, cell 3, things like that can sometimes be a little bit problematic, especially if you come back to this 2 weeks later or 2 years later, or you give it to somebody else. And so one of the things that I've thought about a little is how you can maybe add more information, sort of tag variables using some extensions of the Python syntax and ways to sort of integrate that with Jupyter. So I'm not going to go into this in great detail, but if you're interested, there's a website, dataflow.nb.github.io, looking at sort of this idea of how you facilitate efficient exploration and maybe not lose your way along the way, and also thinking about improving the outputs there. So there's some Jupyter Lab sort of extensions that help out with that. All right, but the other piece that I want to talk about and what I want to spend more time on here is just Python visualization. So we saw some work in notebooks with C++. We've seen other tools, sort of independent tools, Vapor and Visit and ParaView, VMD. And so there's this, a lot of people do work in Python, and there's just this explosion of different libraries. Some of them sort of building off of existing Python libraries, some of them taking different tacks and things like that. And so you can see this slide sort of highlights the complexity of all those things that are in there. There are other things as well, links to ParaView, things for geospatial analysis, like PyDeck and things like that. And I want to focus in on a couple tools because they kind of take different tacks at visualization. One is Matplotlib, which if you've done visualization in Python, you've probably encountered before. And it has, some strengths. It's quite proven and well tested. Has some links back to MATLAB in terms of the syntax structure. You can kind of do almost anything you want with it. There are some weaknesses in sort of the imperative API. Wasn't really designed for today's web where notebooks run, right? Notebooks run in the web environment. Some of the styles might be a little dated if you look at some of the original sort of Matplotlib defaults and things like that. One of the things to sort of understand about Matplotlib is how it constructs a figure. A figure can be composed of different axes, and you can have multiple axes in one figure. And then you have like a y-axis and an x-axis inside of this axis structure. You can have titles for each one of the axes, labels for things like that, and many more different pieces that sort of go into building figure. A different sort of newer kid on the block is a library called Altair. And it's really based on a JavaScript library called Vega Lite, which is browser-based. And one of the things that it tries to do is focus more on specifying sort of the what instead of the how. So instead of saying, draw these lines with this data, it's sort of take this data set, want it to be encoded in a certain way, use this attribute to encode this attribute as color and things like that. Because you have this change from Python to JavaScript, that is a bit of a weakness. There's some things with loading larger data and things like that that do cause some issues. There are some ways to get around that as well. Here, I mentioned this declarative visualization. One of the ways that Altair and Vega Lite try to view the world is in terms of sort of marks and channels. Marks being kind of the geometry, how you take a data item and convert it to something in the visualization, whether that be a point in a scatter plot, or a line in a bar chart, or maybe an area on a geospatial plot. Kind of analogous to like paths in Illustrator. And then you can style those paths with dashes or line thickness and things like that. Altair has those same sort of primitives type things. And so the idea then is after you pick up one of these marks, you can sort of add in different channels on top of it. So, you know, use color, use shape, use where the position of the points or the lines are, the area, the size of a particular mark and things like that. But the idea is that you create a data item for each mark, or create a mark for each data item, and then you take different attributes from that data item, you know, height, width, age, things like that. And each one of those can sort of be mapped onto that mark via one of these visual channels, like color, hue, or shape, or size, or things like that. All right. So with that, I want to move on to some examples. And so there's some airfoil data that's on Cooley. Since Cooley's up, you can go to jupiter.alcf.anl.gov and click on Login Cooley there. The notebooks that I'm going to be using are in the track 4 examples of the project site, that path right there. So if you want to look at these, probably the easiest thing would be to copy them to your home directory. There's 2 of them in there, airfoilflow.ipynb and airfoillineplots.ipynb. And then another option is sort of to, you know, download them or something, and then there's a way to upload them into these notebook interfaces as well. So again, if you want to follow along, the notebook files are in the track 4 examples directory. You can copy them to home and then point your web browser at jupiter.alcf.anl.gov, go through the login procedure on Cooley. And if you move them to your home directory, you should see them listed there. So I'm going to exit this, switch on over. So again, if you go to jupiter.alcf.anl.gov, you can click on the login Cooley button. It'll walk you through the steps there. And eventually you'll see basically a listing of your home directory with whatever files are in there. And if you've copied in the IPYNB files, you can click on them and they'll open in another tab so that you can look at those notebooks. The data for these examples comes from the fast math team. It uses modular finite element methods, a simulation there. And so the 2 pieces of the data set that we have are velocity, magnitude, and angular sweep. So with matplotlib, Python code, import a bunch of libraries, needed modules, define some variables. And again, I'm doing this in different cells here. I'm going to look at, say, one particular file here. So just append that onto the path name. There are better ways of doing this using os.path or pathlib and things like that. But this will work for now. And then I can load that data in. And so in this case, it's just an array, a NumPy array. So just a normal array here, floating point values. You can look at the shape of that data. And there are ways to reshape the data. So in this case, it's just sort of a one-dimensional array, but we might know that, you know, this was output in such a file, but really we want it to be 1024 by 1024. So that reshapes it a little bit. And then matplotlib has ways to show that data as an image. So that line here, im show, is a way to show that data. And so we can sort of see here, you know, there's the airfoil, there's some space around it. And we'll get to that a little bit later here. One thing we can do is make a bigger image by setting the fig size parameter here so that we can get a bit of a bigger image here for that first. This is just the first frame then of that simulation, the first iteration. One thing with this yellow data that's kind of problematic here is we haven't flagged one of the values that was output, this -1000 value, as sort of invalid data. And one way I can do that is set that value instead of -1000 to np.nan, and then re-render that. And I can start to see some of the more detail there about what's actually varying there, right? That was kind of washed out when I had these really low values in the original data, right? So that starts to bring out some of the information from the visualization. Can also change the color map, right? So this is Matplotlib's default color map, Viridis, I believe, probably pronouncing it wrong, but you can change it to more of a red-blue color map instead. And there are many other color maps. One of the things with visualization to be, you know, has been alluded to before is be careful of what color maps you use. Probably don't try to create one yourself. There's a lot about perception and the way that sort of the luminance of different colors can sort of play tricks on your brain when you're looking for particular patterns using visualization. Another thing I can do is maybe set that invalid values, right, the bad values from the color map to black instead here, make it very clear where the airfoil is. I can also clip the color map, so try to bring out some of the values, clip those values to kind of show a little bit more of the patterns where I care about them. And then some pieces where I can change the title, the labels on the visualization. So right, that anatomy of a figure, try to change some of those pieces there. And you'll notice that this code, if you haven't worked with Matplotlib before, is sort of this sort of stateful sort of commands, right? So I do plt.title, plt.ylabel. That's sort of a global method call that sort of acts on the current figure. So for a given cell, you sort of have a new figure for each cell, and then those commands apply to that figure. Right? But now I can add information about the title, the axes labels, and so on and so forth. Can even do things like change the font, right? Increase font size, you know, change the weight of the font and things like that. Another thing that's often important in interpreting the data, especially when using color, is some translation from what the colors you see to the actual values that that color is encoding, right? So a color bar is something that Matplotlib can just add automatically here for you. And we can add, you know, a label again to the color bar and change some pieces about that. Oops. Add some arrows on the end to sort of indicate that we clamped the values there. Change a few other things here. So Tommy already showed animation in the C++ kernel, but we can also do this using Matplotlib. So we can go through and run through, say, you know, 61 of the different steps from this sweep data. And sort of create the base figure and then have a function that just swaps the data out here, right? So the set array function is just going to take each one of the pieces of data and swap in a new image here from the data that's been run from the simulation. And so you can watch it sort of generating and adding those outputs to the notebook. And so that sort of runs once here and sort of resets. And there are different ways you can sort of zoom into these figures. This is using an interactive mode for Matplotlib Notebook. But another way that you can do this is to generate more of an HTML JavaScript version of the animation. Takes a little bit of time. But then this provides, smaller, this provides the ability to sort of go through the loop, right, and have it sort of loop through and continuously loop through and see this. So again, you can get these animations out. You know, maybe the end data is, you know, something that is amenable to this sort of 2D visualization. You don't need to go to some of the other tools that exist. Matplotlib may be a way to get some insight quicker for some of the data that you have. And then I'm going to jump over here to the line plots example to just show a little bit of the difference between Matplotlib and Altair. Altair isn't, as far as I remember, not installed on sort of the default Cooley install. You can run this line to install a user version of that. I already installed it, so I won't go through that before. But I can read in the data again. And in this time, I'm going to use that pandas library, sort of read my data into more of a tabular format. So I can look at the time steps, the min, the max, and the mean values. I can plot that information using Matplotlib actually directly from pandas. So there's sort of a plot interface from pandas that knows how to translate those to Matplotlib plots. There's also ways to transform the data so that I can look at the min, the max, and the mean at the same time. Right, sort of get an idea of how that data spreads out. Sort of the distribution spreads out as time goes along. And there's, again, another shortcut for that. With Altair, things are a little bit different in that I choose the geometry, that mark type, and then I choose how I want to encode things like the position here, so the X and Y position. So I'm going to use the step on one axis and the max on the other axis, right, and I get that line plot. And Altair tries to be smart, and through Vega Lite tries to be smart about some of the visualization rules that exist. So things like showing 0 in a plot, even though that makes it a little bit harder to see the deviation here, right? So if you want to explicitly turn that off, you have to set some flags to say that you are going to allow the y-axis not to start at 0 here, so you can see a little bit how things change. We can also look at things like that max, mean, and min plot created here. One of the nice things that, because this is JavaScript, right, you can kind of zoom in on particular areas. You can have these interactive sort of plots. There are features for that in sort of the notebook version of Matplotlib, but Altair makes that a little bit easier in that you can have multiple of these open. It's a little more amenable to the notebook visualization interface. Here's another piece. And one thing we can do by building up these different primitives is create a plot where we sort of fill in where the values fall. So we'll create an area mark as well as 3 line marks here. Right? And what that has the effect of is drawing the 3 lines from the data, as well as sort of drawing this region that shows where those values fall by shading in that region there. Right? And so this idea of thinking about the more sort of basic geometric primitives and sort of how you map the data to them and then how you encode them sometimes can be a little bit easier than sort of figuring out what the drawing commands are in order to get that, right? It's more sort of telling the library what you want and then having the results kind of rendered for you. All right, so that's a whirlwind tour of different visualization libraries and how you can interact with them in Python through notebooks, as well as sort of this idea of thinking about how notebooks change how we do sort of data exploration and data explanation, right? The sort of features that are added there. And so I think that's some important things to think about how that changes how you're working in these notebook environments. Thanks.
Thanks, Dave. Are there any questions for Dave? I think we have a couple minutes.
Yeah, so the Altair module not found, there's that pip install -- user piece at the beginning of that oh yeah, so you could, if you run that, excuse me, I forgot to say, if you run that line, you'll probably have to go to restart the kernel. So there's the kernel menu there, and there's a restart option under the kernel menu that often is required to sort of restart some of the pieces for Jupyter to pick those up. That might be what's going on. So the connection from notebooks to publishing. There are some interesting examples out there of how people have made notebooks available as sort of a sort of first artifact of their work. There's some nice examples that I know Jupyter has shown off from the LIGO work, sort of showing, stepping sort of the public through some of the steps of how they did the analysis and sort of made some of the conclusions from that. I don't think that it's, really a solved problem. There are some ways to output notebooks to things like LaTeX, so you can include pieces of them in that sort of a publishing workflow. But going from sort of basic explorations to more of an explanation that gets published, I think there's value in some iteration in there, right? So just sort of saying, well, here's my raw work, and I want to sort of press a button and magic, it turns into a paper, doesn't make any sense. And so I think sometimes people who rewrite notebooks and things like that, there's a lot of value to that, and translating that into a paper and things like that. But there is some value to, here I did some scratch work a couple months ago. Now I can pick that up because everything else that was on the stack got lifted. I can go back to that and, man, I don't remember what I was doing. Can I sort of make sure that that's structured in a way that I can get back to it? That's more of the problem that some of the data flow notebook work is trying to solve.